is a NEET Odisha 2019 question from collisions. Look at the question. A particle of mass 5 m at rest suddenly breaks into 3 fragments. 2 fragments of each of mass m moves perpendicularly, each with a speed v. What is the energy released during the process? So let's try to understand what he has given for you. A particle of mass 5 m. Its initial mass is 5 m. Who is at rest? Being at rest, we can say initial kinetic energy of the system is half mass 5 m, but velocity is 0. So initial kinetic energy is 0. Now what he is saying is it is divided into 3 fragments. One of mass m moved perpendicularly with a velocity v. One more having same mass moved perpendicularly. So out of 5 m, m and m are gone. Where does the remaining 3m goes is the kind of question we can say. We can say being a collision or an explosion, always momentum is conserved. What is momentum conserved means initial momentum equal to final momentum. What is initial momentum? Mass into velocity. Mass is 5m, initial velocity equal to 0. Final momentum is mv. You can call say it's an x-axis, so you can say I cap plus mv j cap because it's along y-axis. Remaining is 3m, and in which direction it goes and what is its velocity we don't know. So initial momentum equal to 0, mv I cap plus mv j cap plus 3mx. So you can say 3mx is equal to minus of mv I cap plus mv j cap. This is a vector. You want its magnitude? You can say root of x component square plus y component square. So minus comes, but anyway, even if you write minus mv whole square, that minus goes. Minus mv whole square. So 3m of x equal to square root of m square v square, and 2 is there. That is root 2 times of mv equal to 3m of x. M and m gets cancels. So x equal to root 2 by 3 times of v. And let's worry about the direction, though it's not relevant to the problem, just for a second. This mv and this mv are perpendicular. The resultant will be somewhere in between these two. Root of m square v square plus m square v square, resultant momentum. That is p1 bar plus p2 bar. This one and this one. As the total sum equal to 0, I can say p1 bar plus p2 bar plus p3 bar equal to 0 because initial momentum equal to 0. So p3 bar equal to minus of p1 bar plus p2 bar. This is what we have written here also. This is what. I'm just trying to give a visual picture of that. So P3 has to be opposite of resultant of these two. As P1 and P2 are like this is the direction of your P3. This is how it moves. Though it is not asked in this problem, I'm just trying to create a kind of awareness for you. Once you got this P3, once you got this initial velocity 2, final velocity of the third part, I can write final kinetic energy. Final kinetic energy is kinetic energy of the first piece, second piece, and third piece. First piece is half m v square. Mass is given, velocity is given. Second piece is also half m v square. But the third piece is half out of 5m because m and m are gone. Third one is having a mass of 3m. Velocity of the third piece we have already calculated. Root 2 by 3 of v whole square. So how much is this? Let us simplify. half mv square plus half mv square plus half 3m. Root 2 whole square is 2. 3 square is 9, v square. So if I have taken half mv square common, 1 plus 1 plus 3 into 2 by 9. Everything else is common. So half mv square of 2, 1 plus 1 is 2, 3 into 2 is 6 by 9. Half mv square of 2 plus 6 by 9 is 2 by 3. Half mv square of this LCM is 6. 6 plus 2 is 8. So LCM is 3 and 2 into 6 is 6. 6 plus 2 is 8. 8 by 3. So half mv square of 8 by 3, you can cancel that to 4 by 3 mv square is the final kinetic energy. He is asking what is the energy released, that itself is energy released. Therefore, what we can say? Energy released is Ke final minus Ke initial. Ke final is 4 by 3 mv square, but Ke initial equal to 0 because it is initially in the state of rest. So 4 by 3 mv square itself is our answer for the problem. That's how we solve the problem. So while solving this problem, we have discussed a lot of things. So I want you to understand them carefully so that you can solve the other problems also easily. Direction of the third piece will be helpful in solving the other pieces of the problems. I simply used the conservation of momentum and found the velocity of the third piece. Using that, I found the final kinetic energy, simply substituting in the formula half mv square. Energy released means Ke final minus Ke initial, but Ke initial equal to 0. These basic aspects are used while solving this problem. That's it. Thank you for watching.